Okay, so for this one, we have to find V1, V2, and V3 of this circuit. So first thing we see is that if there was a current moving in this direction or a current moving this direction, it would be really difficult to solve for it as there's no resistors to help us with. So what we're going to do is we're going to do a super node. So let's say there's a current moving in this direction. It starts off from V2 and it leaves through the positive terminal of this source, so it increases by 10 volts, and it'll be equal to what's ever left at the end. It'll be equal to V1, and that's the equation for this portion. And then for this one, let's say there's a current moving in this direction. It starts from V2. It increases by 5 volts because this is a dependent source. It's dependent on whatever the value is here to get the voltage source here, or the voltage value there. Okay, so it'll be increased by 5 volts and it equals to what's ever left at the end, so it'll be V3. Now we wrote the equations for these two, so now we can treat both of them as one super node. So this is one whole node, and for this one, it's also one whole node. And you see these two nodes both connect to each other, so this whole thing is one entire node. So anything that enters this node is equal to anything that leaves this node from anywhere in the circuit. So if it's something is entering here, and something is leaving here, those will both be in the same equation. So we see there's an I here. Let's write it here. We see I is leaving this the node. Let's say I2 is also leaving this node. Let's say I3 is also leaving this node, and let's say I1 is leaving leaving the node from here as well. Okay, so let's write the equation. So I1 is leaving plus I plus I2 plus I3, and there's also I1 is also entering from this portion, so I1 is entering, and then we can see that the I1s cancels out, so it'll be just 0. I1 plus I2 plus I3 equals 0. Now let's figure out these I's. So I will be equal to V1 over 2 because it goes from high potential to low potential, and this is the ground, so it'll be 0 volts down there. So it'll be V1 minus 0 over 2. I2 will be V2 minus 0 over 4. And I3 will be V3 minus 0 over 3. Now let's plug these in. So we have V1 over 2 plus V2 over 4 plus V3 over 3 equals 0. Okay? Now, also, so we have one equation with 3 unknowns, so that means we need 2 more, and we can get those 2 other equations from here. But first thing we see is we need to find a way to get rid of this I, or else we really can't solve it. But we see I is equal to V1 over 2. So it'll be V1 over 2 here. So it'll be 5 times V1 over 2, or 5 over 2 V1. Alright, so we got our 3 equations. So let's start by plugging them in. So for the V2 plus 10, let's plug it in for V1. So this will be V2 plus 10. Hold on. Wait. Let's go back. I think I missed something. Okay, so it'll be V2 plus 1 plus 10 over here, all over 2. Okay, so V2 plus 10 over 2 plus V2 over 4. Then we have V3. We see V3 is equal to V2 plus 5 V1 over 2. So it will be V2 plus 5 over 2 V1 all over 3 equals 0. Okay? Now let's try and get rid of this V1 as well, so we can have everything in terms of V2 and solve for V2. So again, we see V1 was equal to V2 plus 10. So let's do that. Let's write down a separate line. Okay, and now let's simplify this portion. So let's distribute the 5 over 2 into everything. So it'll be 5 over 2 v2 plus 50 over 2, which is 25. And then v2 plus 5 over 2, that's 7 over 2. v2 plus 25. Okay? Now 7 over 2, if I'm not mistaken, that should be 3.5. So that's 3.5 v2. And let's break this up. And same here, let's break this up. Alright, let's collect like terms. So v2 over 2, that's 0.5 v2, plus 10 over 2, that's just 5, plus v2 over 4, that's 0.25 v2, plus 3.5 over 3 v2, that's 1.1667 v2, and 25 over 3, that should be 8.333. Now let's collect like terms. So this one, and this one. I get 1.9167 v2. Then we have this one and this one. So it's just plus 13.333 equals 0. Now we can solve for v2. So let's bring the 13.333 to the other side. So it will equal minus 13.333. Divide both sides by 1.9167. And we get v2 equals minus 6.959. Now, with this information, we can solve for the other two. So for v3, no, let's solve for v1 first. So v1 is equal to v2 plus 10. So v1 is equal to v2 plus 10. v2 was minus 6.959. So v1 is equal to 3.044 volts. Now let's solve for v3. So it's v2 plus 5 over 2 v1. v3 is equal to v2 plus 5 over 3 v1. So it's minus 6.959 plus 5 over 3, 3.044. And if you put all of that into your calculator, you get 0.652 volts. So those are your final answers.